Welcome back. Hopefully that wasn't too bad. Keep in mind that when it comes to interviewing, interviewers want you to know that you understand the concepts. You won't necessarily have to code a binary search tree from scratch, most of the time at least. Because in real life you have things like this library that somebody else created that allows you to use tree traversal and manipulation techniques. Because this has already been done before. And you can see by using a library like this that you can just use it and create the tree that you want. Most likely, you're not going to implement it from scratch by yourself. But we do want to understand the fundamentals and how it works. So if this was challenging to you, don't get frustrated. This doesn't make you a bad engineer or bad coder. You're just working towards building those fundamentals, so that you can use tools like this in the future and still understand how they work. But enough talk. Let's get to the answer. I want to create a tree that looks something like this. So the first thing I'm going to do is work on the insert function. Now, within this insert function, the very first thing I want to do is to say, well, we want to create the new node. And we'll say new node will be the value. So we're just creating the new node class, instantiating it with the value, and that's our new node now. So we have a reference to it. The first thing we want to check, well, if the tree is empty and there's no root node, well, we should add this as our root node. So I'm going to say this.root equals null. If that's the case, then simply make the root node our current node that we inserted. Nice and easy. And just to check that this is working, if I comment all of this out and click run, there you go. Our root node has a value of 9. Left is null, right is null because it's the only node. And by the way, to show you how this stringify works, it's really, really useful because if I copy this and just point out here that I'm not copying the quotation marks, which makes it a string. And if I open up Developer Tools in Google Chrome, and I go to my console tab, I can copy and paste this, press enter, and now I have access to this tree. And it's a lot easier for me to view. And once we insert other nodes, you'll see that it's very easy to traverse this tree this way and check your work, which is why I added this function. So we'll come back to that. For now, we see that our insert is working, at least for if the root node is null, but let's continue if that's not the case. We'll say else. If the root node is already filled, we'll say that the current node will be the this.root because we're going to have to traverse this node. And we won't know how long we're going to traverse this node for. We just want to keep traversing until we find a place to insert this. And this is a bit tricky, but something you'll get used to when you're building trees. We want to use a while loop, and the condition we're going to use is true. That means just keep looping every time because true is always going to equal to true. And we have to be careful here. If we do this, we want to make sure that there is a way for us to exit out of this loop. Otherwise, we're going to have an infinite loop and we'll crash our little page here. So what are the conditions that we're going to loop through? We want to traverse through the tree. Well, the first check we're going to do is say if value is, remember, value is what we insert. If that is less than the current node.value, so we'll start from the root node and say, hey, is the value that we're entering less than the current node value? If that's the case, we know the rules, so we're going to go left if the value is less than the current node. Now, in here, we want to check, first of all, if there's no current node dot left. Is there an element already to the left of the root node. Because if there isn't, in that case, we can just assign the current node dot left to our new node that we want to enter, because there's nothing there. And we can just return out of this loop and just return our this, which is the binary search tree. However, if there is something to the left of our node, let's say in this case 9, in that case, we'll say current node is going to equal current node dot left. So we're going to update and shift over so that the current node is no longer 9. It's whatever is to the left of 9. And that's going to keep us looping. So we're just going to keep looping, keep looping, keep looping until we hit a node that doesn't have a left-hand side, so that we can place the current node or our new node into its place. But that's for the left side, if the value is less than the current node. If the value is greater, or in this case equal to our current node, and we can decide here where we want to place values that are equal. That's up to us and how we want to implement it. We'll say that we'll go right if value is greater or equal to current node. In that case, well, we want to do the first check first, which is if current node dot right, there's nothing to it, there's nothing next to it, to the right of it. In that case, just like above, we can say current node dot right equals the new node. And we're also going to return this because we want to stop looping. Remember, as soon as we have a pointer to null, that's when we want to exit out of this while loop that's going to loop forever. Otherwise, we simply say current node is going to equal current node dot right. And there you go. Hopefully this works. But before we test this out and see if we made any minor mistakes, I do want to warn you. If you are just coding along, I encourage you to pause the video and think through line by line, maybe even drawing things out, maybe using Visual Go to see what we're doing. Because it's really hard to keep this in your head. Even myself, I can't code this from scratch. It takes me a bit of time to think things through and see how we want to structure the code. So don't feel frustrated if this is a bit overwhelming. I encourage you to pause the video, try to code along and understand what's happening step by step. All right, let's test this out. I have an insert of 9 here. If I click this run, that's working. If I insert 4, all right, looks like 4 got inserted. What about 6? All right, I'm just going to comment all of this out and see if that works. I'm going to click run. All right, looks like we've logged out everything, but I want to test, make sure that everything is working as expected. So what I'm going to do is I'm going to copy and paste this, remember, without the quotes at the end, because I don't want to copy the string. I want to copy the object, and I'm going to, again, open my developer tools, go to console, clear my code, and then just copy and paste, hit enter, and now we can test our tree. Let me scroll down here. This is the tree that we want. We have 9 at the top. To the left and to the right, we have 4 and 20. Look at that, that's good. And when we go to the 4, we have left is 1, right is 6, awesome. And 1 should have null null to the right and left, perfect. Same with 6, perfect. And if we scroll down, let's look at 20. It should have 9, or it should have 15 and 170 as its children. We have 15 and 170, and both of those pointing to null. Hey, not bad. Not bad at all. It wasn't too bad. Once you get a hang of it and code this on your own, you'll see that it makes sense. It's all just logic and something that we've learned when working with linked lists. In the next video, we're going to try and tackle lookup. If you weren't able to implement insert, Please try and do that now before we get to lookup. Otherwise, try to implement lookup on your own, and I'll see you in the solution video. Bye-bye.